Hello everyone, welcome to day 22nd of March Leetcode channel, and today's question is Vowel Spellchecker. In this question, we are given a list of words and a set of queries. We need to tell whether the queries matches with any of these words or not. And there are few rules that we have to use while checking whether the query matches with the input word list or not. The first one is the capitalization case, wherein you can do an in case insensitive checks while querying the word list. Similarly, there are vowel errors. You have to treat all the vowels as a single character. A, E, I, O, U can be treated as a single character, and while checking whether this particular query is in the word list or not, you can replace A by E or E by I or I by O or O by U, any of these. I'll explain both these rules in my presentation in a lot of detail, and there are few more rules that are specified here. So let's move on to the presentation. There we'll have an elaborate explanation of the question. So let me just start the slideshow, and let me just take a pen. Leetcode 966. So as stated in the question, we have a list of words and we have list of queries. We need to check which query maps to which word in the given list. And let's talk about the interesting part. What rules are specified in the question? The question says you need to ignore case sensitivity. That means you need to do a case insensitive check while querying the words from the word list, except the case where the query exactly matches a word in the word list. This will be case sensitive. I'll explain both these cases in this test case. And there's another query that says when the query matches a word up to capitalization, you should return the first such match in the word list. So let's talk about the case where you have yellow spelled like this, and the query is YELL capital O and W. So the first said ignore case sensitivity and do the check in the word list. So this, if I do a case insensitive check, it will match yellow in the word list, and I have to return yellow, whatever it matches. Awesome. And then we have yellow spelled capital YELL single double L O and W. So this also matches with this. Awesome. This also matches with this. So for all these three cases, we'll have to return yellow as an answer. Also, there could be a case where you have another element in your word list. I'm going to highlight this rule that it should match the first found match in the word list. So let's assume hypothetically that in the word list there was another word YELLOW. So this is capital L followed by a small l and small o and then a small w. So this also matches, all these words also matches with this word in the word list. If you do a case insensitive check, let me just rewrite this: y small, e small, l capital, l small, o small, and then w. So all these three words matches with this as well. But what we have to return the first instance that matched in the word list, which would be this yellow, not this one. Had there been the case where this was not there, we would have used this as an answer. Hope you understood the second rule. And let's talk about another rule that was specified in the question. For the case when the query exactly matches a given word in the word list, you should return the same word back. This is a case sensitive check, not case insensitive check, rather a case sensitive check. Let's take this as an example. We have yellow spelled capital Y, capital E, small l again, small o and small w. And if I get yellow, the same word, then you have to return it back, something like this. And next we have small y in the word list, small e in the word list, capital L twice, small o and small w. And if I get a query with the same word, then I have to return that same word rather than the first matching word, which is this. So the answer would be this, not yellow, yellow. Hope this rule is also clear to you. Let's move on to the next rules. The rule says treat all vowels equivalent to each other, and we can generate a pattern out of it and replace all the possible instances of a vowel in the string by a star, hash, any special character that you want to keep. Also, when you query a word that matched to the vowel errors, you should return the first matching one in the word list, similar to what we discussed in the previous example. And let's take the cases for both of them. So we have yellow, as in YELLOW, and if I generate a pattern out of it where I replace all the vowels by star, is Y star, L star, L, small l, and then again a star and then W. So this is the pattern that is generated, and for all these words, if you generate a similar kind of a pattern, then it will match this character, this word. So we need to return a yellow from here, which exactly matches to the same pattern. I hope this part is also clear to you. Also, if I had another word followed in the word list spelled like Y, capital E, or capital O, L, L, U, W, then the answer would not be this rather than this, because it was the first matching one. So it is the first matching one. We have to return the first matching one whenever there are multiple possible answers in the word list. I hope this rule is clear to you. And let's talk about the last rule, which is a pretty simple rule. There it says if there is no matching string in the word list, then you have to return empty. Quite straightforward. And let's talk about the actual logic now. So I have created 5 columns here. The first one specifies the input list. The second one specifies the lowercase string of the input list. The third one specifies the vowel removal rule, and I generated a regex out of it. And then the fourth one signifies a hash set of the input of the word list. And the last one is a pattern match, where I have created a map of string comma string, where the first one signifies the pattern and the second value, the value is the actual match in the word list. So let's try and build our pattern map and hash set. In the first step, we will do some processing on the word list and generate our pattern map and build our hash set. Let's try and understand what we are doing here. And for each string, the first string is capital K, I, capital T and E. Let's just first dump it into the hash set. So hash set gets a new entry. Let's just convert it into the lowercase string. The lowercase string would be this. Let's just remove all vowels from the lowercase string and generate the vowel key. So vowel key would be this. And using these two keys, let's check whether there was some entry in the pattern map or not. It was not there. Both were empty. So just dump entries into the pattern map. And for kite, we get kite as in spelled here. And for K star T star, we get this entry. And the next word is kite. So what is the lowercase string? It's kite. What is the vowel removed string? It's this, the similar one that was we did in the previous case. And we put an entry in the hash set. So we get kite, added kite here. And since both the keys were already present in the pattern map, we'll not do anything. We'll move on to the next string. We get here HARE. And the first thing that we're going to do is to add it into the hash set. Hash set gets a new entry. We'll generate a lowercase string. We'll generate the vowel removed string, H star, R star. And since both of them were not present in the hash map, so it gets 2 new entries, HARE, HARE for the lowercase string as the key, and the word list as the actual value, the word is as the actual value, and the vowel removed string, H star, R star as the key, and the actual string as the value. And then we have HARE. So we dump HARE into the hash set, and we generate the lowercase string HARE and then the vowel remove string. Since both of them were already present, we are not going to do anything, just move ahead for the next iteration. The word list is exhausted. Awesome. And let's do the querying part now. We first get kite, and the first step is to check in the hash set itself whether there is an exact match as in the word list, if it is there or not. And in this case it is there, so this string matches. So the first output query will be kite. And let's move on to the next case. So we get capital K, I, T and E, and let's check it in the hash set. It's not there in the hash set. What we are going to do, we'll generate a lowercase string of this. So the lowercase string of this would be kite, as in written here, and we will check it in the hash map, the pattern map. So in the pattern map it exists. What with the value, corresponding value, K, I, T, E. So capital K, I, small I, capital T and E. Let's move on to the next iteration. We have capital K, I, capital T and E, with there is an exact match in the hash set, so that would be the answer. K, I, T, E. And let's move on to the next case. We have HARE, capital H, and there is an exact match, so that would be the answer. And next we have capital H, A, capital A, R and E. There's no such entry in the hash set. What we are going to do, we'll generate a lowercase string. Lowercase string would be this, and we'll check whether there's an entry in the pattern map. The entry exists, it does exist, and we will return the corresponding value. So it gets HARE. And then we have HEAR. There is no such entry in the hash set. Let's convert it into the lowercase string. The lowercase strings are these HEAR, and it doesn't match with any of these keys. So let's generate the vowel removed keys. The vowel removed keys for this string would be H star star R. So it doesn't match with any of the vowel removed keys. That means there is no such entry in the pattern map, and we'll just ignore that. So it's again kind of similar. And then we have KT. So KT is interesting. Let's check whether this entry is present in the hash map. It is not. So let's generate a lowercase string for this. Lowercase string will be KETE itself, something what is written here, and no such lowercase keys are there in the hash map. Let's generate the vowel removed strings. The vowel removed string will match. So let's just return the corresponding value, which would be kite. So we get kite. And similarly you can do for the other two as well, on very similar grounds. First is to check into the hash set, then if the value is found good enough, then you generate a lowercase string and you check whether it matches with any of the possible lowercase keys. If it does, you return the corresponding value. If not, you move ahead and check whether you generate the vowel removed string, and you check whether it matches with any of the vowel removed keys. If it does, you return the corresponding value. If it doesn't, then that's the last case where you need to set it to empty. The answer would be empty for that query. I hope this logic is clear to you, and let's move on to the coding part. So the first step is to define a hash set of type string, and let's call this word set new hash set, and let's add entries into it for each string. In the word list, let's add elements to this hash set. Word set dot add word. Otherwise, let's generate a hash map of string comma string. Let's call it map new hash map, and let's just process the input words and generate the corresponding uh, lowercase strings and the vowel remove string and do entries in the hash map. So this is a pre-processing part even before starting the querying part. String word over word list, and let's generate the lowercase string first. String lowercase str, that would be word dot to lowercase. Pretty simple way of converting it to a lowercase string. And let's do the entry in the hash map. If absent, the put if absent is very important because the first one should be given priority over the others. So we'll use put if absent, and lowercase str is the key, and the word is our actual value. Let's generate the vowel remove string. Get vowel removed str string, and we'll pass string to it. Let's do the entry for this in the map itself, and this time the key would be vowel remove string. And now let's process for the queries. Let's do the processing for the queries. String integer I equals to 0, I is less than queries dot length I plus plus, and the same logic, the 3-step process. Let's first of all check if word set dot contains the queries, the current word to be queried, and if it has, then let's just continue because we need to return the same string back. So let's just continue the process because the word set already contains the input query string, so you don't actually need to do anything. Otherwise, if map dot contains key, and let's generate a lowercase string for the input query, lowercase query, that would be queries of I to lowercase. And once you have done this, let's check it in the map. If it is there, then let's update the query of I equals to map dot get lowercase string. So we'll get the corresponding value for the lowercase string, and if it is there, then let's just continue the process. Otherwise, let's generate the vowel removed query. So let's call this vowel removed query, and let's generate the vowel removed query input string for this, the key that needs to be searched. And once we have that, let's check it in the hash map. If map contains, then let's get the corresponding value and update the answer query. Otherwise, if none of this matches, then let's just update query to empty. And once we are done with this, let's just return the queries back. So this is our data. This is the variable where we are keeping the answer set, the answers, the corresponding answer to the input queries. Use the same space. And let's just generate the vowel removed string. Right, let's write the helper method for it. String word And how are we going to do that? Let's write a for loop. I equals to 0, I is less than word dot length I plus plus. Even before that, let's generate the character array word char word dot to char array, and if my word char of I happens to be equal to a or u, a e I o u, a e I o u. Sounds good. If that is the case, then let's just update the word char to star. Awesome. So I made a small error in code that while generating the vowel remove string, you need to first convert it into a lowercase and then apply the logic on it. So I added two lowercase here, and let me just submit it and try this up. Accepted. What is the time complexity of this approach? The time complexity is order of number of queries that we have, plus we are processing the word list and building the array, and for each word list at max we have to add two entries. So number of elements in word list into 2. Sounds good. And let's write the space complexity as well. Space complexity is order of n, where n signifies the number of elements in the word list, since we are building a hash set using it. I hope you enjoyed this, and thanks for watching it.